Hello guys, welcome back to our course and now to our 2 practical lectures about XSD. In this lecture and on the next, we're gonna see all the XSD files we've seen so far since the first topic, XML, until the last theory lecture about XSD. And the schemas we're gonna implement now, as well as the XML instances we're gonna use to validate against them, will be generally on the same order we've seen on the theory lectures. So let's begin with the animal group XSD. For you create any XSD file, you open Eclipse and you create some project or directory, and then you click the right button, New, Other, XML schema file. Then you click Next. And for the animal group, let's use animalgroup.xsd as the name of the file. Then click Finish. Let's maximize it here. Okay, for organizing the attributes of the schema element of the XSDs, you can just use the shortcut Ctrl-Shift-F. Okay, now we are ready, and we've just adjusted some things here for keeping our standard. So the first thing is the prologue, as always. Then we open the declaration of the schema element using the access default prefix, which is linked or associated to the default namespace for the XML schema from W3C. Then we declare the target namespace, which in our case will be this one, my domain / animal group. Next, we define a custom prefix for this document, which we've been calling Daniel PM 1982, and we associate this custom prefix with a custom namespace, which, as you remember, must be exactly the same as the target namespace we wanna link. So through this custom prefix and custom namespace, we link the access to the target namespace of this document, and we can refer to any element of this document using this custom prefix, as well as we can access any element from the default namespace using the access default prefix. And next, we set the element form default as qualified, which we've already discussed. It defines that any instance of this XSD document, in order to use the elements and attributes and types we define in here, must use these namespaces. In our case, we have these two, the custom and the default, and not the components directly. So next, as we'll be using the named types design method for this XSD document, we set the simple types, then the complex types, and later we set the global root element. So let's declare the simple types So here is our first simple type, which is a simple name type for declaring a name, in our case a name of an animal, using the access column restriction nested to the simple type, and a base attribute for the data type, in our case access column string, inside or nested to the restriction element we include all facets we want. In the case of this simple element, we include the max length facet, defining a value of 20, which means that this string type will accept at most 20 chars. And for avoiding empty spaces, we use also the white space facet with the value collapse. If you see here, the white space can have three values: the preserve, on which empty spaces are preserved, the replace, and the collapse. We're gonna use almost always the collapse for eliminating all empty spaces from the XML instances inputs. So this is the first simple type, and now let's declare the others. Okay, this is the second simple type, which is the species type, which is also a string type, simple type for a simple element that will contain the species description. And in this case, the facet we're using is only the enumeration facet or constraint over that string data type. And for this enumeration, we have three values, which are the species for dog, for cat, and for rabbit. If you remember, this is a schema that defines an animal group, and for which we have three types of possible animals: a dog, or a cat, or a rabbit. And this is the simple element that declares the simple type for the simple element of the species of each element. This is the simple type for the simple element, which will describe the color of the animal. Now let's declare the other type. Okay, here is the other simple type, which is the birth date for each animal at our schema. And for the base attribute of the restriction, we're gonna use the date data type. from the default namespace. And inside the restriction, we're gonna use two facets. One is the pattern facet, which receives, for example, an expression language. In this case, an expression language that defines the data format as 4 digits hyphen 2 digits hyphen 2 more digits. So this would be the year, this is the month, and this is the day of that date. And down here, the white space facet as always. Now let's declare another one. Okay, here is the last simple type for this XSD document. And if you see here, it's also exactly the same definition of two other types above, which are the color type and the name type. And this simple type is the owner description type, which will be set to the owner element. And just for showing you that it is possible to generalize our types, I'll just make a generalization of these three equal types to a generic type called string type. So this, instead of the name, the color, and the owner types, we're gonna have only one string type that will be set to those three respective elements. So we can delete the simple type color type, and we can also delete this owner type because it's exactly the same of the string type, and we reuse the string type. So we ended up with three simple types: the string type, the species type, which is an enumeration, and the birth date type, which is a pattern of type date. So now let's declare the two attributes that we're gonna use. One at the nested animal elements, and the other at the animal group root element. So we declare the attributes globally, as we did for the simple types. Okay, here are the two attributes we're gonna use: the animal ID, which we're gonna use for each animal declaration, and the group ID, which we're gonna use for the whole instance of the animal group. And the type for both would be a non-negative integer from the default namespace, and as default value we're gonna let the 0 value. And at the instance, if the user sets any value, this new value overrides this default one. Now let's declare the complex type. So at this first complex type, which is the animal type, which will be set to the animal element later, we use an indicator, in this case the sequence indicator, which means that these elements, when they are used at the XML instances, they must follow this order or sequence. And the nested elements we use at this animal type are the name for the animal, and as the type we use the string type we've defined above, with the min occurs indicator with the value 1, which means the value is required. The second nested element is the species, and the type is the species type, or the enumeration above, also required. Then we declare the color element, and the type we reuse the string type above defined, also setting the value as required. Next we define the birth date and set the type as the birth date type we defined also above, but we set the min occurs as 0 or optional. And lastly, we define the owner name, also reusing the string type we declared above and setting the value as optional. And after closing the indicator, we set the attribute for this animal type or for the animal to which this type will be set later. And for the attribute, we refer, using the ref attribute, to the global attribute we've also declared above, animal ID. And we set the use attribute of this attribute as required. And next we declare the complex type, which will be set later for the root element. So at the last complex type, we've nested each animal describer, the name, species, color, birth date, and the owner name. And now, the animal group type, we add a sequence of unbounded elements called dog, cat, and rabbit, and in the 3 cases of type animal type. So this last complex type is the one we'll be setting at the root element below. So here observe also that this last element, which is the root element, is the only global declared element. If you see, all other elements are declared nested to the complex types. And this last complex type, which includes all 3 possible animal elements, dog, cat, and rabbit, and also the last complex type with all possible simple types, this last complex element is the one set to the only global defined element, which is the animal group future root element. So at the instance, we're gonna use the animal group as root element. And this animal group will have an animal group type, which will turn available the use of the dog, the cat, and the rabbit elements, and the description for each of these three animals will be this first complex type, animal type, with the name, species, color, birth date, and owner name of each animal. So the root element is the whole group of animals, which can have dog, cat, and rabbits in any number of elements, unbounded, and each of these animals, dog, cat, or rabbit, can have as description elements these elements here: the name, the species, the color, the birth date, and the owner, which in turn refer to the simple types we declared above, including the two attributes. So now let's test some instances that refer to this XSD document for confirming that the instances validate against this XSD, which, as you can see, is a well-formed XSD. There are no problems detected on the syntax of the XSD itself. So, other than the correctness or well-formation of the XSD, now let's test the validation of some XML instances that refer to this XSD. So I've copied here two XML instances already created before, and that we've already discussed it on the two practical lectures of the first topic about XML. And let's just see, as a review here, what these XML instances have related to the XSD documents. So here is the first XML instance, always beginning with the prologue, then opening the root element declaration and using as attribute the XMLNS column XSI with the default namespace from W3C for the schema instance, XML schema instance. Then through that XSI default prefix, we get the schema location and set the target namespace of the XSD along with the XSD file name, and then we define a custom namespace with the URI exactly the same URI of the target namespace for that XSD we are referring to, and we set this custom namespace to this custom prefix, the UPM 1982, and we use this custom prefix for getting access to the elements and attributes and data types defined at that XSD. So first, the animal group, which is a global complex element. Remember that we gotta use the custom prefix here also for the root element. Then we set the group ID as an example with a value of 1, which is the group ID number 1. Then we declare as many animals as we want, but always in the sequence: dog, and then cat, and then rabbit, because we've used it as the order indicator, the sequence indicator. So for example, if we used a dog element after a cat, for example, you see that even if we change it, the values here, it would not comply with the XSD, because in this case we are using at the XSD the sequence indicator. So also, as we've declared the dog, cat, and rabbit elements as unbounded, we can use as many elements as we want, as long as we obey the order set inside the sequence indicator. So at this example, I'm describing a dog with an animal ID of 1, and the name, species, color, birth date, and owner name for that dog. Then I describe a cat, or actually two cats, a cat A and a cat B. And lastly, I declare or describe two rabbits, rabbit A and rabbit B, with and without the optional elements, which in our case are the birth date and the owner name. So here I use those elements, and here on the last rabbit I only use the required describing elements, which are the name, the species, and the color. So this is a complete instance of an animal group. And also regarding the data types, for example, at the species, which is an enumeration, if you press Ctrl space here for using the auto complement, you see that as this instance is already referring to that XSD, it shows already the 3 possible values for the species, which are the possible values for the enumeration we've declared at the XSD, which are the Canis familiaris, Felis catus, and Oryctolagus cuniculus, which are the species for each of these 3 possible animals. The species for the dog, the species for the cat, and the species for the rabbit. So in the case of enumerations, you can use the autocomplete from the IDE to see which elements are possible. And in the case of the name, it's a simple string of 20 chars. If you try out more than 20 chars, it won't accept. You gotta have at most the max length of 20, as we've set at the XSD. In the case of color and in the case of owner name, it's the same. At most, you gotta have 20 chars. And in the case of the date, as we've declared the pattern as 4 digits for the year, hyphen 2 digits for the month, hyphen 2 digits for the day. For example, you can't put January because it won't match, and also you couldn't put, for example, 1/01/2005. For example, this pattern also wouldn't match the required pattern for this field. So these are the types we've defined, and the elements and the indicators we've set at the target namespace of that referred XSD. So that's it for the animal group. Okay, now let's see another set of XSD files on which we're gonna demonstrate how to import and how to include different XSD files into one same XSD file, and later use that one XSD importing or including file at the instances that would refer to it. So first, let's implement 2 simple XSDs called Note1 and Note2 schemas. And later, we'll use those Note1 and Note2 schemas to show you how to import them and how to include them into a unique XSD for later use. So first let's create the Node1. Open the Eclipse, click on the right button, New, Other, XML schema file. Let's call it Node1 XSD. Finish. Let's maximize here. Use the shortcut Ctrl-Shift-F. And now let's organize according to our standards here. Okay, this is the schema element declaration and all the namespaces and prefixes defining attributes. Nothing new here. Just have in mind the URI for this first node schema, which ends in node1. It's the node1 schema. Now let's declare the simple types, which are pretty simple. For the node1, the simple types are the from type, the to type, the message text type, and the date type. So let's declare them. So here there are all the simple types declared. The first one, a from type, which represents the origin of that node. It's a node schema with an origin and a destiny, or a sender and a receiver. And the from type represents the type for the from element, which will be the origin of the node. The to type represents the destiny or recipient of that message. The message text type represents the text of the message itself with a facet max length over the string type of 1,000,000 chars. So at most it will have 1,000,000 characters. And the last simple type of this schema is the date type with a restriction of base date time. And as with the last example with sim, the animal group example, if you see the from type declaration and the to type declaration, you see that these two types are exactly the same. They both have a restriction of base string and nothing more. There's no specific facet in any of them. So we can also use generalization here and later use that generic type for both the from as well as for the to elements when we declare these elements and define the type with the type attribute. So let's use a generic type here, for example string type, and let's delete this to type here. So we have only these three simple types now. The string type with a restriction of base string, the message type with a restriction of base string and a facet max length of value 1,000,000 chars, and we have the date time simple type with a restriction of base date time. Now let's declare the attribute. Okay, this is the globally declared attribute of the node ID that will be used at the future root element and with the type non-negative integer and a default value of 0. Now, after we define all the simple types and the attribute, let's declare the complex type, which will group all these types and attributes together, and then will be set to the globally declared future root element. Okay, here is the complex type we're going to define, called node type, which is a sequence of simple elements from, to, message, text, and date, time, and each one of them will refer to the globally declared simple types above using the type attribute. So the from and the to will both refer to the string type simple element. The message text will refer to the message text type with the facet of max length equals to 1 million chars, and the date time simple element will refer to the date time also declared above. And then right after closing the sequence indicator, we declare the attribute referring to the globally declared attribute node ID and setting this attribute as required. And now let's declare the globally declared future element and set this complex type to this future root element. So that's it for this schema. If you see, there is nothing new on it, but after we create the other node schema, the node2 schema, we'll use both this node1 as the node2 schemas for showing you how to import and include schemas at a third XSD. So now let's create the node2 schema. The node2 schema will be very similar to the node1. I'll just change the names of the elements and types. So I'll just copy and paste here the node1 and rename to node2 and change some things on it. Okay, here is our second schema, the node2 schema. I've taken as the base the first one, and I've changed the URI to node2, both at the target namespace as at the local custom namespace. associated to the custom prefix. I kept the string type as the same for the origin and for the destination types. I changed the second type to a content type of base string and of max length value 64. So it will accept at most 64 chars. And I kept also the datetime type as well as its base. I changed the attribute name to message ID, and I kept the type as non-negative integer with default equals 0. And at the complex type, I changed the name to message type as well as the names of each element to origin, destiny, both of which with string types, content of type content type declared above, and the datetime of type datetime type. And after we close the sequence indicator, we set the attribute referring to the message ID attribute declared globally, also set as required. And lastly, we set the future root element named node, and we set the complex type here at the future root element. So this is a very similar schema to Node 1, but I just wanted to demonstrate that you can create any number of different schemas with different names for each element. And now we will demonstrate how to import these two different schemas to a third different XSD, and later use that third importing XSD for linking to XML instances. So now let's create the third XSD, which will be the importing one. Let's call it node all import dot maximize it, Ctrl Shift F. Let's fix some things here. Okay, these are the attributes of the schema elements, defining the target namespace of this third schema, node all import, and a local custom namespace associated to a custom prefix, the NPM 1982 as always. And now let's import those other two schemas, node 1 and node 2, by using the XS column import element. So for importing into and importing XSD file, other XSD files with different target namespaces, observe here that we have different target namespaces for each of the XSDs being imported. So for the node1.xsd, we have a target namespace ending its URI with node1, and for the node2xsd, we have a target namespace ending the URI with node2. So it's very important to observe here that we are importing two different XSD files with two different target namespaces, one ending with Note1 and the other namespace ending with Note2. This is the most important condition for you to be able to import by using the XS column import element. So here you import the XSD and all its elements, attributes, and types, but you gotta refer from inside this XSD document to each of these target namespaces. And the way we've been doing it for a long time now is by creating custom prefixes. So we have here a custom prefix, DanielPinheiro 1982, for the target namespace of this document itself, note all import. And now we gotta create two other additional prefixes and local namespaces for linking and having access to the two imported namespaces of the two imported XSD files. So we'll create a prefix for linking to the target namespace of Note1 and another prefix for linking to the target namespace of the Note2 XSD document. So we've imported two different XSD files with two different target namespaces, and we've created two local namespaces linking to their respective target namespaces, and we've associated those with two different prefixes. So with this prefix, DanielPinheiro 1982 Note1 will have access to all the elements, attributes, and types of the first XSD, and through this other prefix, DanielPinheiro 1982 Note2 will have access to the elements, attributes, and types of the second XSD. And with this initial prefix, DanielPinheiro 1982, associated to the Note all import custom namespace, which is the namespace linked to this document itself, we have access to the elements, types, and attributes defined or declared locally at this third XSD file itself. So now let's declare an attribute and a complex type using the elements and types of the imported XSDs, and later we'll set the complex type as always to a future root element declared globally. Okay, now we finished this third importing schema. So at this complex type, we've declared all imported elements with their respective types. Observe that for each one, we've used either the prefix ending with Note1 for the types declared at the Note1 imported schema, and also the Note2 prefix for the types declared at the Note2 imported schema. So as we see, we've associated those different target namespaces with different prefixes, Note1 and Note2, and later we use it as some element declaration. Each of these prefixes, Note1 for the Note1 schema and Note2 for the Note2 schema, for getting access to the types or eventually the elements or attributes from those imported XML schema documents. So we have the from, the to, the message text, the date time, the origin, the destination, and the content elements declared at this local node type complex element. Then we declare the attribute referring to the mail ID attribute above declared and set as required. And lastly, we declare the future root element node, setting as its type the node type complex type above. So that's it for this importing XSD. As you see, it's pretty simple to import different XSDs with different target namespaces. And a last important thing to note here is that in the case of the XS column import, unless you gotta import XSDs with different target namespaces, there's no risk for conflict between same named elements or attributes or types imported from those XSD documents, because all the elements, attributes, and types will be associated to different target namespaces and locally to different custom namespaces with different prefixes. In our case, Note1 and Note2 namespaces and prefixes. Now let's see the case in which we'll include two different XSD documents but with a same target namespace to a third XSD document. Remember on the last example, the example with the XS column import, we had to import the XSD documents with different target namespaces. But in the case of the XS column include, we gotta do the opposite, which means we gotta import or include the different XSD documents but with a same target namespace, both for the two imported elements or included elements as for the including third XSD document. So we'll have two XSD documents which we're gonna include at a third including XSD document, and all three must have, if we're going to use the XS column include element, all three must have the same target namespace. So all elements, attributes, and types will be grouped or included together in one same target namespace, which will be common for all three. So let's create now the first and the second schemas with a same target namespace to be included later at a third schema. Click the right button, New, Other, XML schema file. The first one will be note1 for including .xsd. Maximize it. Ctrl-Shift-F. Let's fix some things here. So observe here that we're going to create two different namespaces XSD documents, note1 for including and later the note2 for including, but we must set as target namespaces for each one of them a same URI. So we're going to use this URI engine with note all include, both for these two initial schemas, note1 and note2 for including, as well as for the third including schema. All three must have the same target namespace in order for us to be able to use the access column include element strategy. And now let's simply declare some simple types. Okay, here are the four simple types we are declaring at this first schema that's going to be included at the third including schema. And as we've been doing, we're going to generalize these two first ones to a string type. You don't need to have equal types. It's redundant. So we'll keep the string type for a string-based restriction data type. We'll have the message text type with a max length of 1,000,000 chars, and we'll have the date time type of base date time. So that's it for our first schema, note1 for including, and let's now create our second one, note2 for including. I will also base this second one on the first one, and I'll just change some names of the types inside. The target namespace, we've already said it must be the same of the first one as well as of the third schema. So we will let the URI as note all include, and we'll change only the types names. We won't need this date time because we're gonna use already the date time from the first schema, so we can delete it. And that's it for the second schema, a string type and a content type. So this is it for the note2 for including .xsd file. Now let's create the third including schema for including the types of these two other XSD documents. New XML schema file. The name we'll set as noteallinclude.xsd. Let's fix some things here. Okay, now let's include the other two XSD files or documents into this third noteallinclude.xsd document. And for that, we're going to use the access column include. Okay, it's pretty simple. So, in the case of the access column include element or strategy, the only thing you gotta set through its attributes is the schema location file, which are the note1 for including .xsd and the note2 for including xsd. You don't have to set the target namespaces for the included files because it's implicitly set to be equal to the target namespace of this including document. So all three target namespaces will be necessarily equal, ending with noteallinclude. And for having access to the elements types and attributes, you just gotta refer that target namespace to a local prefix and local custom namespace, which we've already done here, and set to the DanielPM 1982 prefix. So this prefix, DanielPM 1982, will give access to all elements defined at this third XSD, as well as for all elements, attributes, and types declared at the included XSD documents. So everything is included into a single namespace and referred by a single prefix. So now let's just set some attributes and complex type as well as the future root element for this third XSD. Okay, now we finished the third XSD document, which is the including XSD document. And as we've said, it includes these two other XSDs, Note1 and Note2 for including, and unify all the elements and types and attributes inside one same target namespace, which we associate to a local custom namespace and to a custom prefix. And when we're to use those included components, we just use that single custom prefix for getting access to each one of the included types or elements or attributes. So different from the access column import, with the access column include, and as we include everything into a same target namespace, there's the risk that equally named elements or attributes or types may get into a conflict between them. So we gotta be careful with that. If you wanna use the include strategy, you gotta be sure that there's no element, attribute, or types with equal names at the included XSD documents before you include them to a third or to any other including document. With the import, we have not that problem because everything that's imported is imported to a different target namespace. But with the include, as we include everything into a same namespace, we can't have equally named components. Okay, before we test the validation of the XML instance referred to that node all include XSD file, let's first correct a mistake we've done. When we generalized our simple types at the first schema and at the second one, we ended up letting two simple types with the same name. For example, here at the first one, we've declared the string type of base string, generalizing two other simple types we had, but when we did the same at the second schema, we also let another simple type with the same name associated to the same node or include target namespace. So we must delete one of them. Let's delete the string type from the second schema for correcting this same named type conflict. Then let's check the third XSD again. Okay, it's well formed and no error detected. And now let's see the XML instance that we are referring to, that third XSD node all include.xsd, and to its target namespace ending with node all include. And to have access to that target namespace, we, as always, create a custom namespace associated to a custom prefix, the NeoPM1982, and through this prefix we have access to all elements and attributes and types defined at those three schemas, both at the node of include schema as at those other two first schemas that we included into this third one. So we use the node root element. We also use the from, the to, the message text, the date, time, the origin, the destination, and the content elements whose types were defined at those two initial schemas included at the third one, in which we declared these elements referring to the included types from the other XSD documents. And for testing the validation, click on the right button and simply validate. Okay, the validation completed with no errors or warnings. So these are the two strategies we can use to import or include different XSD files into a third or any other XSD document. Later on a next example, we're gonna see another different strategy, which is to refer to multiple XSD documents from inside an XML instance, which is obviously different from what we've just done. What we've done now was to import or include different XSDs into another XSD and later refer to that single final XSD from any instance. But later we will see that it's also possible to refer to multiple XSD documents from the instances themselves directly. So that's it for the Node XSDs and XML instances. Let's go now to the last XSD document example related to our first topic, XML, which is the patient record XML schema. So let's create a new other XML schema file. Let's name it consultation record.xsd. Finish. Let's maximize it here. Ctrl-Shift-F. And let's organize the attributes according to our standards. Okay, the default W3C XML schema namespace associated to the access prefix. Then the target namespace ending with consultation record. It's a schema that structure a consultation record. Then a custom namespace associated to the custom prefix DNUPM 1982, from which we have access to all elements declared inside this XSD document. And now let's create all simple types to this XSD. Okay, these are the simple types of our XSD document. And these simple types are the name of base string and max length of 50, the gender type of base string and enumeration of values male and female, a birth date type of base date and with this regular expression with 4 digits for the year, 2 digits for the month and 2 other digits for the day. An email type of string base with a max length of 50 and an regular expression for validating the email format. The address type of base string with a max length of 150. The phone number type of base also string with a max length of 20. The consultation date time type of base date time. The diagnosis type of base string and with max length of 500 chars. The intervention type of also base string and a max length of 1000 chars. The clinician type, which is the type of the clinician that's gonna consult the patient. It can be a pharmacist doctor, a dentistry doctor, a psychologist doctor, a nutritionist doctor, a physiotherapist doctor, a physician doctor, or any other doctor or clinician. And lastly, the clinical professional number type of base positive integer, and almost all of them with also the facet whitespace value collapse. So now let's define or declare the attributes. So these are all the attributes of this document that we are declaring globally. So nothing new here. And now let's continue with the complex types now. Okay, this is the first complex type, which is the complex type defining or describing the clinician who's gonna proceed with that consultation with these nested elements: the professional number, the type of professional, the clinician type, the name of the professional, the gender, the email, and the phone number, with the types respectively those declared above: the clinician professional number type, the clinician type, the name type, the gender type, the email type, and the phone number type, with most of them with min occurs of 1, that is required, and with a max occurs of 1 at most, but with the email optional, and with a max of 2 emails for each profession. And the phone number with a min occurs also 0 or optional, and with a max occurs of 3 phone numbers. And the attribute for the clinician will be the clinician ID, and as you see, nothing new at this complex type. Now let's declare the other complex type. Here's the second complex type, or the complex type named patient, which unites the data specific to the patient description, that is the name of the patient, the gender, the birth date, the email, the address, and the phone number of the patient, as well as the attribute referring to the globally declared attribute patient ID. So as you see here, some of these types set to these simple local elements are clearly reused from the globally declared types. For example, the name, the gender, the email, and the phone number of both the clinician and the patient are simple elements that share the same types: name type, gender type, email type, and phone number type. Here at the patient also the same, reuse the name type, the gender type, the email type, and the phone number type. And that's one of the advantages we saw that is characteristic for this design method of named types, as well as also for the divided method, but not for the simple method. So now let's declare the third complex type, which is the complex type for the consultation itself. Okay, this is the consultation complex type, which is a sequence of only 3 elements: the date time for the consultation of type consultation date time type declared above, also a diagnosis element of type diagnosis type, which we set the max occurs as unbounded, because you can have many diagnoses in a same consultation of a same patient record, and also the intervention of that clinician on that consultation of type DNUPM 1992 column intervention type, with a max occurs also unbounded. In this complex type, consultation does not have any attribute. And now let's declare the last complex type, which will be the union of all these complex other types we've declared and all the nested simple types nested to them, which will also be the type for the future root element we'll define next. Okay, now we ended our XSD defining a record complex type with a sequence of 3 elements with types referring to all other three complex types we've defined: the patient type, the clinician type, and the consultation type, which in turn have nested all other simple types declared initially at this document, and the elements are the patient, the clinician, and the consultation. And after the order indicator, we define the attribute referring to the last attribute defined globally, which is the consultation record ID. So lastly, at the end, as always, we declare the only globally defined element, which is the future root element, consultation record, and we set the most complex type we've declared with all other types nested to it as the type of that future root element. So there's actually nothing new at this XSD document. And now we are gonna test two XML instances against it in order to test the validation of those XML instances. But this XSD document itself, you can see that it is well formed and correct. So here are the two XML instances we're gonna test against this XSD document, and one of them we've already shown you at the first topic of this course, which is this one. If you remember, first we start declaring the consultation record root element with the default XML schema instance namespace associated to the XSI prefix. Then we set the XSI column schema location with the target namespace of that XSD we've just created, and with the file name consultation record.xsd. Later, for having access to this XSD, we declare a local custom namespace associated to the prefix DanielPM 1982, and then we start setting the consultation record ID attribute for the root element with a sample value of 1500, and then we start describing and using the elements and attributes for describing the patient with the name, gender, birth date, email, address, phone numbers, the clinician description with its professional number, the type of the professional, the name, gender, email, and phone number. Then the consultation complex element with first the date time and with all diagnoses obtained at that consultation and all the interventions also developed during that consultation. So both at this XML instance as on the other, we've used it as an example, a clinical pharmacy consultation with a pharmacist doctor. It could be any other doctor. If you remember, we've set this element profession as an enumeration type with some types of doctors, including the pharmacist doctor, but with any other doctor which could be part of the clinical team. And for each patient, we have the clinician and we have the consultation itself with a date time, the diagnosis done by that specific doctor or clinician, here the pharmacist doctor, and then the interventions also made by that specific professional on that specific patient in a certain consultation date time. So let's test the validation of this instance example against the XSD. The validation completed with no errors or warnings, and as you can see, it also is correct and with no syntax errors. And now let's see the other XML instance, which is basically the same. It's another consultation with another pharmacist doctor and with a different consultation, even for the same patient. It could be the same or it can be another patient, but at another consultation date time with different diagnoses and interventions developed during the consultation. In this second instance, if you test the validation, it also validates successfully. And so this is a very simple example of a patient record structuring XSD document. So with this, we conclude all XSDs related to the XML instances we showed at the first topic, XML, of our course.